Well, Kalimera. But the first thing that I want to do is to have a selfie picture because I need justification for this trip with my family. They think I am in Athens enjoying, so that's true, but also doing something. And Greeks are famous for being, I don't know, emotional. I mean, loud. So happy. Okay, so do not be like sad. And 1, 2, 3. Yay! Thank you very much. So let's start the presentation about AI code reality. Usually, what you see are presentations about how great is AI, how amazing is AI. I'm kind of sitting on the other side. It's great, it's a tool, it's awesome, but it also has shadows. And I will try to give a bit of data and my interpretation of all of these shadows. Okay. So I will start with 3 numbers. 19% is basically what a study has shown is AI making teams going slower. 0% is the DORA improvement following some studies that teams using AI have been experiencing. And 29%, according to other studies, is the trust that developers are having on AI. So basically, you can see other numbers saying, wow, we are going to take your jobs in 6 months. But the reality is kind of far from there. I will introduce myself. I'm Jonathan. I come from Barcelona. Who has been in Barcelona before? Awesome. For the rest, this is a special year. It's the Gaudí year. So Sagrada Familia, no, it's not finished yet. But they have crowned the Sagrada Familia, so this year is at this top height, let's say. And you can visit the cross on top of it. Well, I'm Java champion, Oracle Ace, and IBM champion. And I've been part of the communities since 2012, being one of the leaders of the Java community, and also founder of 3 different conferences, JVCN Conf, DevBCN, that we have our next edition next June in Barcelona, and also AI for Devs, that it is an AI conference that we host in Amsterdam. I wrote a lot of content in platforms like Dev2, Vue.js. It's an amazing platform if you want to be updated about Java. Definitely, I recommend you to go there. Medium, also Java Pro, several places. And I've worked as a developer for more than 35 years using several languages. I started using Pascal, but the one that has my heart, apart from Java, is Delphi. Anybody has used Delphi before? OK, so I'm not the only old person here. So I was working as a senior staff developer advocate at Sonar, but that was until yesterday. So I've been impacted by a layoff. The good news, I'm starting as an AI development enabler in a German company called GK. So the agenda for today, it's basically, I will try to give you a bit of definition of what poor quality is. Because everybody has a friend that works in a shitty project. Let's see how this, not you, your friend. Let's see how poor quality is. Then I will try to put a bit of numbers on AI code generation, share some best practices, tools, and a conclusion. I will share the QR code for the slides at the end. So, poor quality projects pre-AI. At Sonar, they have a lot of projects, open source projects that you can analyze for free. And they have gathered a lot of data. Yeah. So, what the outcomes of that data were those projects, these old shitty projects, let's say, are hard to read. And we spend 90% of our time reading, not writing. So it's an important part. Now with AI, it's even more. Maybe 120% of our time is spent on reading. But we spend a lot of time finding and fixing issues in our projects. According to another study, it's 4 days per person. These projects are messy, and every time that you touch something, you are afraid of breaking another thing. So there's a lot of things involved. Those projects are vulnerable. And only taking 2023, there were more than 20,000 new CVEs published. So it's a very important part, security and vulnerability. And coupled, again, it's hard to evolve and fix things. And those projects tend to be also inefficient. So I've heard some people that say, our project is in Java 21. What does it mean you are in Java 21? Your JDK Java 21? Or that you are using features from Java 21? That's a different thing. So a lot of projects are not using the latest libraries, features, and methods to solve problems. So going back to the metrics that Sonar collected, well, only in 6 months, they analyzed around 8 billion lines of code. They found 170 vulnerabilities per million lines of code. More than 2,000 bugs, 53,000 code smells. Those are open source projects that apparently, open source projects tend to be cleaner and better than private projects for obvious reasons. A lot of people are looking at them. So those are important parts, but this one, it's a scary one. More than 400,000 hard-coded secrets. Who has hard-coded secrets in their project? Okay, only 4? I will do the question in another way. Who has a friend that has a friend with hard-coded secrets? Okay, now we get it. So my point is, usually, you don't hard-code secrets because you want to mess with your company. But, well, it has happened to me in the past. The product owner or the project manager comes and says, let's gonna create a POC, a proof of concept. You are going to invest 1 week. It's amazing. What you are going to do, we are going to see everything. But I assure you, using the religious book that you want, I assure you on top of whatever, that this won't go to production. So you don't care about security, hard-coded passwords, anything. 2 months later, you see that application deployed in production. Why? Because it was working super fun, super perfect. Why not promoting it to production? Hard-coded secrets. Anybody has a friend that has experienced this situation? Yeah. Okay, so now we have a picture of what real projects are. Well, you know your projects and the projects are your friend, but that was a way of showing, well, the general market. So how can AI can impact this? Let's start to see if we are aligned. Who thinks AI has impacted this in a positive way, so now we have less issues and less vulnerabilities? Don't be shy. It's free. And who thinks it has impacted negatively all these numbers? We are aligned. Perfect. So, AI-generated code. Well, it's going up and up and up, the adoption. So I assume almost all of you are using AI. So in 2026, depending on the reports, and you need to believe those reports, it's 90%. The trust has decreased from 40% to 29%. The acceptance rate is not great at all. According to their reports, 30% Amazon, 40% JetBrains, 30% GitHub. So this means 60 or 70% of the times we reject what they are suggesting. And another problem is juniors are using 20% more AI than seniors. I have 3 possible explanations, and we do a poll. First, juniors are younger and are more attracted to cool things. B, juniors are doing simpler things. Therefore, AI is good for that. C, AI can give you the false illusion that you are better than you are. So it's a fast way of becoming a senior, being a junior. Who thinks is A? Yeah, they are attracted to cool things. Perfect. Who thinks is B, simpler things? And who thinks is C? So this is a big problem. You see, a person without experience, without domain knowledge, thinks they are better than they are. Sonar also produces a leaderboard where they analyze, now today it was 54, 58 models. They run an experiment having 4,000 Java tasks, and they use each of the models, they run those Java tasks, and then they use SonarQube in order to analyze the responses. This is the leaderboard with, I think it's the latest models. So as you can see, the pass rate, so the most accurate model would be Gemini 3.1 Pro, high, but has an issue density around 20 and 300,000 lines of code. The second one is Opus 4.5 that has double the number of lines of code. We will talk about the problem of lines of code, tokens, money. Then we have several ones. And then in the 12th position, we have GLM5. It's an open one. You can download it from Hugging Face and try to host it in your machine. It has to have power. But as you can see, there is no one with a 0 issue density. And depending on the model, you can see that GPT 5.4 has 1.2 million lines of code, when Gemini have 300,000, or GLM have around 600,000. What does it mean? Depending on the model, you're going to pay way more. And the accuracy is not that different. What about the bug severity? Well, now the list changes the order. So now the first one is GLM5, the open one. Is the one that produces the less issues. But it's not the one that produces the less blockers, because for less blockers, we have GPT 5.1. Again, we have another dimension, severity, criticality of the issues generated. And security vulnerabilities. Again, there is no 0 in the list. We are coming from GPT 5.4, 50 and 20 of them are blockers. GLM is having double that. and also 3 times the blockers. Again, it's not an easy decision which model you are going to use, but definitely you need to consider these experiments in order to select which one do you want to use. In the list, you can find open models. It's a reality. Who is using open models internally instead of SaaS models? One. I did a talk in Berlin, and one guy told me they use Qwen 330B internally because he works for a bank, and they are not allowed to push the code to SaaS. And he was super happy with the result of Qwen 3. Qwen 3 is not even in this list. It's down below. So imagine how happy he would be using GLM 5 or Kimi K2. These are open models, and you are only going to pay for hosting them on-premise, or OpenCode can host them. But there are different solutions. And in some cases, they are even better than the others, what you are going to pay. GPT 5.2 has more or less the same accuracy, has almost double the lines of code, and 3 times the issue density. And the problem with the number of lines of code is not trivial, because I assume all of you are reviewing each line of code generated by AI. Or your friend, the friend of your friend, is not doing it, but I assume you are doing it. But it's very hard, depending on the model, having a pull request of, I don't know, 500 lines or 1,000, or even 10,000 lines of code if you are using another model. You are going to review way more lines of code. So definitely it's a thing. If you want to host those models locally, there's a tool, it's a free tool called LLM Fit. It's easy to install. And then it will analyze the resources of your machine, the machine where you install it. And it will give you the list of models that you can host. And, well, the accuracy and so on. You can change and only select coding models instead of general models and so on. So it's a very interesting tool in order to know and try to host models locally. I use Llama, but there are others, LLM Studio and others. So it's very easy to really use local models. So we come to a part where the decision of which model to use, it's not trivial. It's money, tokens, complexity, a lot of things involved. On one side, accuracy, and on the other side is cheaper, less lines of code, less complexity, but probably less accuracy. So depending on the job that you are asking the model to do, you can choose one or the other. If you are asking, create me an application about X, maybe you need a better model, a thinking model, high model. If you are asking to do methods and simpler things that are going to make you go faster, maybe with the smaller models and open models is more than enough. So the issues that models are usually putting in the output, injections, SQL injections, path traversal injections, remote injections. Maybe they are including, again, the vulnerable version of Log4j. It's still downloaded every day. People are not patching that. But the model can introduce these kind of issues. Hard-coded credentials, why not? Because you have a file in your project that you are not committing with some passwords that your agent can have access to. And then why not adding it to the code? Exception handling or resource management, I mean, it can just generate code without the try with resources from Java, and then you can leak memory. Dead or redundant code, and then you could say, well, if it creates dead code, there's no problem. Well, first, the problem will be reading. If someone reads that, and someone will have to review that in the pull request, so you are wasting their time if that code really doesn't have to be there. But it could be that the problem is, it is right that it is there. The problem is that nobody is calling it. So it's going to make your project way more complex to read. Also, it could be that the AI is adding a dependency in your POM. Nobody uses it. Well, what if you are dependency injection and this library is being scanned and a bin is instantiated? You don't know, you're not calling it, no reference in your code, but it's doing something. And it's going to add cognitive complexity to your code, definitely. Talking about the report with that 20%, 19% at the beginning, Meta did a report where they had two teams, one using AI and another one not using AI. Is here anybody not using AI? One. Two. OK, perfect. For those, let's check this fact. Who is thinking using AI is making you faster? OK? So we should change that 20 to 90. The reality in this study is that the perception does not mean reality. The team using AI was investing a lot of time on waiting for AI, on prompting AI, because you need to create good prompts. And now you need to create SDDs. Well, we should have been creating kind of SDDs all time. That was the thing that I was creating 30 years ago. Full documents with a lot of requirements. And also reviewing the output, because now you are reviewing another person output. So you are going to invest a lot of time on that. And we are not talking about a total metric, that it is from conception to deployment and execution. Because if you are going faster, but you are introducing 100 issues that you need to fix later, then the speed is not really what you think. So in this study, reality was that they were 19% slower, while they thought they were 20% faster. So my recommendation is that you measure correctly using DORA if you are really faster than before. One example, in order to make you awake, I know that 40 minutes talks have ups and downs. I want to be up now. So I asked an agent to generate a multi-threading method accessing a URL. This is what the agent created. I will give you 5 seconds to suggest improvements to this code. Anyone? No one? Come on. Thread pool, OK? Thread pool. Another one. Ah, come on, Alex. OK. So the point is, why, if you are connecting to a URL, you are not using virtual threads? It's a perfect use case. But the point here is, the LLM knows about this. But if you don't know, then you are going to be happy with the first answer. The funny thing is that when I did again the question, I said, but this time use the latest Java features. Then it used virtual threads. So the point that I'm trying to make here is, don't ask AI to do things you don't know how to do. AI can be a tool to help you. But you need to know to do what you are asking to the AI, because if not, you don't know if it's the best way, and you don't know how to review it the right way. There is another thing. So I had a Quarkus application, and a very simple one. And I asked the agent, create the deployment file to Kubernetes. 6 lines of YAML. 6 lines, remember. Copilot, then Sonar detected 6 issues in the file. 6 lines, 6 issues. Amazon Q only introduced 2 issues, but come on, it's a 6 lines YAML. Because Copilot didn't know that if I want to generate a deployment file, well, if I want to go to production, it would be nice to specify the memory and CPU request. Because if not, the cluster could just simply deploy my application in a node without resources. And my application will start, die, start, die, start, die until the eternity. Just because I didn't specify the CPU or the memory request. Again, this works on my machine, but it's not eligible to go to production. And this is what happens with vibe coding, even for big ones. Amazon held a mandatory meeting after vibe code triggered major outages. Or Moldbook, 1.5 million API keys exposed. Or Lovable, 18,000 users across 170 apps with EIC. Or, well, you can read them. I mean, vibe coding is a serious thing, even for big companies. I would suggest don't do that. So the challenges with AI generation is, well, the quality and reliability can be seriously impacted if you don't guide the AI the right way. Maintainability, apparently, it should be you who is going to maintain that code in 1 year. So if it's a problem when you review a code and you say, wow, this is a crappy code, who did that? It was you. What happens if it was AI? You don't have a clue about why this is failing. Technical debt, it can introduce libraries you don't know, libraries not well maintained, libraries vulnerable. You are adding and piling up technical debt just because apparently it works. And control, this is a serious thing with AI. You are losing your brain process to control what you produce. You are asking someone to produce someone for you. You kind of review in diagonal, that's fine. Merge it. No different than when we thought it was the perfect idea to outsource entire applications development to India or China. Not because they do things wrong, just because we didn't give them details. We expected that with 3 lines, they were thinking about the whole application, and a lot of companies had to fix a lot of issues with those applications. It's no different than using AI. You are outsourcing your thinking process to another one. So best practices that I can recommend. PRs, again, you should focus on high quality because also this is going to impact the output of future requests to AI. It has access to your code base, so if you have good quality code, potentially it will produce high quality code. Clear logic, robust implementation, and more importantly, it's not about that you review that the code looks fine, it's that you understand the code. You need to understand everything that AI is doing. Because unless you are using an agentic AI code generation chain, when you do git blame, what do you think it shows? Copilot or your name? So you are the owner, or you should be the owner. You should guide the agent, giving detailed instructions about, well, guardrails, about what it, he, or him should produce. Let's use Quarkus, obviously. Latest Java feature, JUnit 5, quality and security, put focus on it. Testing, cover edge cases, whatever. Something that is going to define the whole project for you and for your team. And AI is going to use this when it produces code. Use SDD. Well, SDD or whatever framework or format. It's about creating a document with all the requirements needed. If you send this document to another person, that person should be able to produce what you expect. So you are going to introduce general information. You are going to define the entities that you are going to use, the context, specs, test cases, and even endpoint examples with JSON documents. Everything. And then with this, AI will produce better code. Dependencies. Consider also this point. As I said before, it can introduce tech debt or problems. Even can introduce typo squatting. Who knows what typo squatting is? OK, for the rest, what if the library is called Google dot, I don't know, Google dot library dot my class? And AI, just because it has access to the good and to the bad, introduces the library is called the same, but Google with one O. Same name of the artifact. Group ID, the only difference is one O. It's hard to spot, very hard to spot. But AI can introduce that, and it did. And it caused a lot of problems, because that library was doing exactly what it was expected, plus sending private information to somewhere else. So check the libraries that it is adding and consider the boundaries of your application. It's important to use SAST tools that are going to check those dependencies and find vulnerabilities. Test generation. This is a tricky one. Who uses AI to generate tests from the code? OK. So here you have an example. The method on top. It's a country where you need a method to calculate your tax income. OK? But this country has a deduction. Can anybody spot where there's an error? Well, an error, or maybe this is the description of a magical country. So apparently, if you pay 1,000 or 500 in taxes, and the country has a 1,000 deduction, this country is giving you back 500. This doesn't happen in Spain, I don't know in Greece. But you will never get more than what you have paid with tax deduction. But the important point here is, I ask AI to generate the test. And effectively, it generates a text that checks that it will return a negative value. So if we use AI to generate tests only from the source code, we are going to check that our bugs really happen. So do not only rely on code, rely on business cases. I don't know, Cucumber again? Rely on information that is really defining what the test should check. Cucumber, BDD, so don't use only the code. With team dynamics, again, do not rely only on AI. It's important that the team share knowledge, that all the team members share the information and learn. and uncover not covered cases, or business request fulfillment, or even there's a case where if you don't document it before and you ask AI to connect to a database, it will create the method to connect to the database. But maybe in your code base, you already have methods with a lot of logic that imply the connection to the database. And AI, if you don't specify before, it will not know. So it's important also that you review that in order to check for those usages. Also, I would suggest to include test checks that are rejecting pull requests longer than a number of lines of code. Then you prevent super big pull requests generated by AI. Also, there are some problems with tools being used in AI. MCP servers, for instance. Who's using MCP servers? OK, from you, who has checked the code of those MCP servers? One. Who runs those MCP servers in sandboxed instances? So for the rest of you, majority, you are swallowing those MCP servers, and you don't know. You expect that they are not malicious. So it's important to give tools the least privilege principle. Don't let AI to just simply full access to your database. Maybe it can think that to change a field, it needs to drop the database before. So don't do that. Use hooks that can check the output of the agent result, or can check that you are not sending sensitive data on your prompt. There are tools and libraries to check that. Check and validate MCP server ownership and code. It's important. And run MCP servers isolated. If you are running them using Docker, they have a function called sandbox, and they will, if you use Podman, you can do also the same, as far as I know, with IP tables, and then you can restrict the connections outside of the container. Use subagents. If you use one agent and you create a lot of things, and you have 1,000 MCP servers installed, all the definition of all the MCP servers is going to be added to the context window every time. So either you use a gateway for MCP, that it's going to have only one definition that says this MCP is doing this, and then the agent will use this to select which MCP server is going to use, or better use skills. Skills can be accessible for the agent, and it will use the title for them, and then it will decide which one to run without having to add all the definition and the tools published into the context window. So finally, the success, as I see it, is that AI can be a multiplier, but a multiplier of what you are really doing now, or should be. You, with good practices, TDD, BDD, documentation, clean code, whatever, teamwork in order to spread the knowledge. A lot of information, you need to create a lot of detailed information of what you are doing or the decisions that you are making. And finally, super important, you need deterministic tools. AI is not deterministic, it's probabilistic. You need something to add determinism to all of this. Tools like, I don't know, SonarQube or Sneak or other tools will give this determinism to your life cycle. Tools, as I said, use SAST, SCA or DAST from the IDE. What happens in your IDE is like in Las Vegas. What happens there stays there. So it's better to catch your issues, your problems, before doing the commit and then push to the pull request. So use them as early as you can. They are going to check code smells, bugs, vulnerabilities, but also best practices. If you are using a platform thread when you should be using a virtual thread, some tools will warn you. Some tools will warn you that you are not using the right method or the right library. So use them. So finally, I think that you need to use high-quality base. You are going to use different agents with different models, as we've seen. It's not like one model to rule them all. No, there are several models. You are going to use different tools to provide information to this chain, coming from GitHub, from Jira, from Sonar, whatever. But important, there's a human in the loop that gives consistency, determinism, and quality to all of this process. To wrap up, basically, I think code quality and security is super important now, before, and in 1 year. Gen AI is great, but needs revision, needs guidance. It's important to also think about which LLM to use. As we've seen, there are several with different characteristics. And use tooling, deterministic tooling, from the IDE up to the CI/CD environment. And always keep a human in the loop. And my last recommendation is we should stop using the word AI. There is no intelligence on this. We should talk about a tool, a model, LLM, whatever, but not intelligence. This has been misleading a lot of people. And again, it's a tool to help, but not to replace anyone. Well, maybe some CEOs will be replaced. And remember, this is my my sentence. AI will give you time, but not confidence. It's up to you to give confidence to the result. Code quality, but code is a verb. And review, always review the code that you generate. Here you have a QR for an article that I created about best practices to work with agents, skills, and MCP. And finally, this is the QR with the feedback and slides. If you can give me bad feedback, I will appreciate it too. Good feedback, thank you. And that's it. Ευχαριστώ πολύ.